Hello. So today what we're going to do is we're going to talk about perpendicular lines, right? So this is actually just the only other part of our unit that we're doing on linear relationships. So perpendicular lines we've run into in the past, just like we did with parallel lines, right? So let's just kind of run through this. Perpendicular lines is when we have two lines that intersect, right? And it's not just that they intersect at a 90-degree angle. Right, so they need to intersect perfectly with a right angle between them, right? So one's going exactly in one direction, the other one's going 90 degrees from there, right? So you can kind of think about like a compass, right? The north-south and the east-west are perpendicular, right? They are 90 degrees from each other the whole way around. So when we're talking about the slopes of perpendicular lines, this is where things can get a little bit funky. The slopes are what we call opposite reciprocals. Right. So when we're talking about opposite reciprocals, they're just, they're generally going to be two fractions and they multiply to give us -1, right? So that's how you can check and make sure that you have opposite reciprocals, and that's what we're going to be doing a little later, is you multiply them together. If you get -1, then you're all set, right? So when we're trying to figure out the slopes of parallel lines, remember that we're going to need opposite reciprocals. So what the heck does that even mean, right? Well, let's practice with number 1 here, right? So on your paper, if you got the version from me, you got this little handy-dandy box of stuff over to the side. Talks about, all the different equations. It's talking about where the slope is. So these ones, just like when we were talking about parallel lines, the slope is just hanging out in front of the x, right? So when I'm grabbing the slope of this line here, it's just -3/7. But we want to be perpendicular, right? So that means that we are going to need to find the opposite reciprocal of that slope, right? So to find the opposite reciprocal, right, we've got -3 divided by 7. All we're going to do is we are going to flip it, right? That's what it means to take the reciprocal, right? We're just flipping the fraction head over heels, right? And then we are going to slap a negative on it, right? Make it its opposite, right? So when I'm finding the opposite reciprocal of this, instead of 3 on the top and 7 on the bottom, it's 7 on the top and 3 on the bottom, right? As far as making it the opposite, right, it was negative because it was -3/7. So now the opposite of that is going to be positive, right? So this is actually what we want to get to right there, 7/3, right? So again, opposite reciprocal, just flip it. If it was negative, leave it positive. If it was positive, make it negative, right? Let's take a look at this second one as well. All right, if you're feeling like you want to give it a shot, pause here, try it out. We've got our slope that's already there, right? 7/9. If I'm trying to make that into its opposite reciprocal, actually, let's make sure we try and color code, make it a little bit clearer. If I'm making it an opposite reciprocal, I need to start by flipping the fraction, right? Just flip it top over bottom. And then what we need to do is make it the opposite, right? What I had was +7/9, right? There was no negative sign in sight. So my answer that I'm going to get when I do opposite reciprocal, right, is going to have to be negative, right? It needs to be the opposite, right? Hopefully that doesn't seem super duper crazy, right? It's one of those things where if it clicks, that's awesome. If it doesn't, it can seem really kind of strange about like, what are we doing? All right, so hopefully it's kind of clicking a little bit. Don't overthink it is, I guess, the best advice I'll give you. All right, for something like this one, right, just like you can see over to the side of your paper, right, when we have something in standard form, we have our little shortcut, right? Our slope is equal to A, slap a negative on it, and divide by B, just like it was when we were doing parallel lines. All right, so the slope on this one, right, the A is 2, the B is -5. So the A was 2, slap a negative on it. The B was -5. -2/5 is the same thing as +2/5. Right, so that's like our starting slope right here, right? So that's the slope of that equation that we've got up top. But I don't necessarily want that, right? I need it to be able to figure out my actual answer I want, but that's not the one I want to finalize my answer on. What we need to do now is find the opposite reciprocal of that. All right, so again, flip it top over bottom, and because it was positive, make it negative, right? That's what we're looking for, -5/2. Right? What I want you to do is pause here, try out the b part, right? Take whatever's in the a spot, slap a negative on it, divide it by b. That's going to give you your starting slope. After that, try and find the opposite reciprocal of that. All right, so hopefully you paused and gave that a go. All right, let's take a look together. So on this one, again, my slope is whatever a is with a negative on it, divided by b. The a is 3, the b is positive 5, so it's going to look something like this. Negative 3 over positive 5. All right, so again, that's the slope that's part of the equation that we just had up top, right? What I need to do from here is I still need to get the opposite reciprocal. So I got to flip it, and that's going to be 5 over 3, right? So flip-flop the numbers. And because it was negative, we're just going to leave it positive, regular old 5/3. Oops, let's make that a little nicer. Right, that's all we're trying to get to. Right, so flip your fraction. If it was negative, make it positive. If it was positive, make it negative. Right, so opposite reciprocal, that's what we're doing. Something to talk about is, I mentioned we can check and see if they're opposite reciprocals by multiplying them together. If they equal -1, then they're opposite reciprocals. All right, so let me scooch some of this around a little bit. I know that you don't have the ability to do this on your paper. So if you got a little bit extra space somewhere, you can try to sneak this in, maybe along the side. Right, but if I multiply these together, right, I've got -3 over 5 times 5 over 3, right? Those are the two opposite reciprocals I had in this problem. When we're multiplying fractions, right, and only when we're multiplying fractions, right, because we're going to get into adding and subtracting a little bit. Right, so when we multiply fractions, we multiply the top by the other top. -3 times 5 is -15. We multiply the bottom by the other bottom, 15. When we go ahead and simplify that, right, -15 divided by 15 gives us -1. Right, so that's kind of our check to see if we do have opposite reciprocals or not. You don't need to do that on every single problem, right? It'll take you a long time if you wanted to check every single one, right? So hopefully you get a little more confident in like, oh yeah, this is what I'm looking for, right? But if you do want to double check, that's how I'd go about it. Okay, so we're going to kind of follow this the same way that we were doing with parallel lines, right? I'm not showing number 4 because I did out number 4 for you already. So for number 3, we want to get this in point slope form, right? So that's that form we got off to the side. It's that y minus y1 and then m and x minus x1 in parentheses. So similar to what we were doing with parallel lines, I'm going to start off the same way. I've got this point that I want to go through, 3, -2. That's my x1 and my y1. Over here, I've got the equation of the line that I want to be perpendicular to, right? So, unlike the parallel ones, we're not just grabbing this and running, right? That's the slope that we want to be perpendicular to, right? So what I need to do is I now need to convert that into its opposite reciprocal, right? So again, just like we were doing, flip-flop the numbers. So 2's on the top and 3's on the bottom. It was negative, so now we're just going to leave it positive. That's the slope I want, 2/3, right? After that, it's just a matter of throwing it all together, right? We've got y minus the y1, which was -2, equals the m on the other side, which is 2/3 that we just found out. And then in the parentheses, we've got x minus the x1, which was 3. All right? So over on the left side, notice that I made sure to grab both of those negatives that are supposed to be there, right? There's the one that's built into the equation, the y minus y1. And then because we're putting in -2, that negative also comes with us, right? Just clean this up a little bit at the end. We can turn that into one big plus sign. And this is what we're going for, right? That's what we want to try and end up this problem with, right? So number 4, right? The example right below this is not all that different, right? Give it a shot, right? See if you can figure out what it's supposed to be. Right? So hopefully you pause there. If not, pause now. Give it a go. It's not going to hurt. On that one, again, same kind of process. I've got my x1 and my y1, which are both 5s in this case. As far as my slope goes, I had -5/4, and to get the opposite reciprocal, I turned that. I flip-flopped the numbers, so it's 4 over 5. And because it was negative, now it's just positive, right? I pop all those numbers into the equation, and then that's it, right? Didn't even have to worry about any double negatives turning into plus signs here. Right? Let's keep on going. So on this one, we want to get it into slope-intercept form and be perpendicular, right? So just like over to the side, right? We're going to start with point slope. We're going to convert it to slope intercept, getting that y by itself, right? So what I'm going to do here, same old deal. I'm going to start with my x1 and my y1. To find my slope, I need to look at the equation they're giving me. So the equation is telling me that my slope is 4. So this is going to be a little bit weird. Let's kind of talk through it. So a slope of 4 means that it's the same thing as 4 over 1, right? You remember that when we're graphing types of things like this, and you've got just a 4 as your slope, we think about it as 4 over 1, so we have a rise and a run, right? That's also going to be helpful to us when we're doing these opposite reciprocal things. So instead of having 4 over 1, when I'm taking the opposite reciprocal, I'm flip-flopping the numbers, so 1 over 4, and it was positive, so now I'm going to have it as negative, right? So negative 1/4 is what I'm trying to get to there, okay? So let's take a look at what this is going to be. We're going to start off the same way we did on the last couple. We got y minus the y1, which in this case is negative 3, equals the m on the other side, that negative 1/4 we just found, and then x minus the x1, which is 2. All right. So I'm going to warn you, this is going to get a little sketch, right? We're going to be working through this. There's some fractions involved, and they might not always work out super nicely for us, but we're going to talk through it together. It'll be all right. So just like last lesson, what we're going to do is we're going to get rid of those parentheses. That means, in this case, that I'm going to need to multiply that negative 1/4 into those parentheses to clear them out, right? What I can also do, and what I should have done even a little before that, is clean this left side up so it's a plus sign, right? So we're going to have y plus 3 equals negative 1/4 times x is just negative 1/4 x. And then negative 1/4 times negative 2, right? So let's kind of work through that. So again, somewhere off to the side, wherever you have space, I would suggest don't write it in this space right below, because we're going to use that to solve the rest of the problem. But somewhere else, we've got negative 1/4 times negative 2. All right, so just like we've talked about in the past, like actually just a second ago, right up there, we were talking about how 4 is the same thing as 4 over 1, right? We're going to do something similar here. Negative 2 is the same thing as negative 2 over 1, right? So now we can go ahead and multiply these, right? The top multiplies the top. We're going to get positive 2. The bottom multiplies the bottom to give us 4, right? So 2 over 4 is what we'd get out of that multiplication. We can also reduce that. We can make it into 1/2, right? 2/4 is the same exact thing as 1/2, so that's not a bad thing to be able to do, right? So we'll say plus 1/2 for that positive half that we have, right? So that helped us take care of that piece, right? And again, somewhere on the side of your paper, I'm just going to slide that over to the side just so it's a little bit more out of the way, right? Nothing, try and clutter up the screen a little less. Right. So from here, what we need to do is we still need to get that y by itself. To get rid of it, to get it by itself, we need to get rid of the 3, which means I'm going to have to subtract 3 on each side. Right. And you might be seeing the next kind of gross thing we're going to have to deal with these fractions. Right. So we're going to get y equals negative 1/4 x, right? Nothing changing there. But then what's 1/2 minus 3, right? You might be thinking like, oh yeah, well then it's just negative 2.5, right? Negative 2.5. But let's kind of talk through it, because sometimes the numbers won't work out quite as nicely as they are here. Right? If I have 1/2 minus 3, a rule that we have for fractions is that when you're adding and subtracting, they need to have the same denominator, right? The same number on the bottom. So when I have 1/2 minus 3, I can't do that right as it is. So what I'm going to do is I'm going to try and turn that 3 into something that has a 2 on the bottom of a fraction, right? So if we think about 3, right? So, I'm a little bit hungry. Let's talk about pizzas. Say I had 3 pizzas. If I was thinking about how many halves I have, if I have 3 pizzas, right? If I split them all in half, right? If I think about how many halves I have 1, 2, 3, 4, 5, 6 halves, right? So hopefully you'd agree that having 3 is the same thing as having 6 over 2, right? 6 halves. Right? So that's exactly what I'm going to do. I'm going to treat that 3, right? I'm just going to rewrite that same thing. I'm going to treat that 3 as 6 over 2. Right? We just talked about how that's the same thing. So then this becomes a little bit easier, right? When we're adding and subtracting fractions, when we have that same denominator, it's just the tops that we worry about, right? This is like 1 minus 6. 1 minus 6 on the top gives us negative 5, right? On the bottom, you might be tempted to do, oh, you're at 2 minus 2, but we do not want to do that, right? We're just going to leave it the same, right? So think about it this way. If I had 1/2 and I subtracted 6 halves, right? What I have is I have negative 5 halves, right? I haven't changed what they are. I just changed how many I had, right? So we're still working with something over 2, but I just changed how many of them I had, right? So negative 5 over 2 is exactly what we're going to get that'll help us finish off that equation, all right? So hopefully some of this fraction stuff is coming back from years past, right? If not, please be sure to ask about it when I see you during class, right? The fractions are something where if it doesn't click, especially it's going to be a little rough, you know? It might not make a whole lot of sense. So please ask if you're getting a little stuck on it, right? Once we get to there, that's where we want to be, right? So just like before, what I'd like you to do is try out example 6, right? The one right below this. I will put everything back on the screen that we did for this problem, including a little squiggly divider between those two different things we did with fractions, right? So try out number 6, unpause when you think you got it. All right, so hopefully gave it a go, right? This is what I got. All right, so you can see that I started off the same way, x1, y1, got my opposite reciprocal for the slope and plugged it all in at the start there. All right, so from here, what I did is I distributed into those parentheses. Right? When I did negative 1/3 multiplied into that positive 4, right, I got negative 4/3. Right? Then we had to add 2 to both sides, right? When I added 2, right, I had to think about it as something with thirds, right? 2 is the same thing as 6/3. So I just added that, right? And again, just like I was mentioning, think about it kind of like we're adding and subtracting with the tops and the bottoms stay the same. So negative 4 plus 6 gave me that positive 2 over 3, right? And again, if this is something that's getting a little like, I don't know, right, be sure to ask about it. That's what I'm here for, right? We got another one to talk about with all sorts of equations flying around. We're going to get this one into standard form, right? So just like on the side there, we're going to start in point slope. We're going to get it to slope intercept, getting that y by itself, and then we're going to drag all the x's and y's together to get it to standard form. All right, so I'm going to start off the same way we've been doing. We got our x1, y1, and then I need to grab my slope right on out of there. So my slope is negative 2/7 in that equation we want to be perpendicular to. So when I'm trying to get myself into something that's an opposite reciprocal, I'm going to flip-flop the numbers. And because it was negative, I'm going to leave it as positive. All right, so 7 over 2 is the slope that I want to use. All right, so let's give this a go. We're going to start off y minus the y1 equals m that we just found, and then x minus the x1 in parentheses. All right, from here, I'm going to kind of zoom in on that part because might need a little bit of space, so try not to write too super big. What we're going to do is we're going to distribute into these parentheses. All right, so y minus 2 stays the same. 7 halves times x is just 7 halves x. And then 7 halves times negative 2 is going to come out real nice for us, actually. We're going to end up with negative 7, right? If you don't believe me, again, off to the side somewhere, maybe on the very edge of the paper, you can write this out. We've got 7 over 2 times negative 2, right? So last time we multiplied with fractions, we thought about that as being over 1. I multiply the tops together to get negative 14. I multiply the bottoms to get 2. And that does simplify to be negative 7, right? So, and you might get tired of hearing me say this. When we're multiplying with fractions, we got to be real careful because it's not the same as when we're adding with fractions. When you are multiplying with fractions, the top multiplies the top. The bottom also multiplies the bottom, right? When you're adding and subtracting, you leave the bottoms alone as long as they have the same denominator, right? So it's something to be careful of, right? So I am going to erase that just so I have a little bit more space to work with. Right? We are going to get negative 7 out of that. Cool. So from here, I'm trying to get that y by itself. Let's move that 2 over to the other side. All right, oh my goodness, it's going to be so nice. We don't have to worry about fractions and adding right now. -7 plus 2 is -5, right? After that, we want to now get all our x's and y's to be on the same side. All right, so that means that I'm going to have to subtract 7/2 x to move that over to be with the y's. All right, so we've got -7/2 with an x plus a y equals a -5 on the other side. All right. So I think last time I might have mentioned the standard form is a little bit nitpicky when we're getting to our final answer, and we didn't need to worry about it last time. Well, this time, unfortunately, we do. So in standard form, we want this starting coefficient, right? The coefficient on x, right? We call it the leading coefficient. It's not something that you have to really remember or write down, but that leading coefficient in front of the x, we want it to be a positive whole number. Right now, it is a negative fraction, so we got problems, right? So the way that we're going to handle that is we are going to need to multiply to get rid of the fraction, right? It's going to be pretty easy. All we need to do is multiply by whatever the bottom number of the fraction is, and that'll help us clear it out, right? So I'm going to multiply everything in there by 2 to get rid of that. The other piece is that it's negative, right? So to take care of that, we just multiply by a -2, right? So you just take whatever you needed to do to get rid of the fraction, multiply it by the negative of that, right? So what's going to happen is that fraction is going to get it, the bottom's going to disappear, right? That 2 on the bottom is going to be gone, and the negatives are also going to cancel each other out. So we're going to be left with 7x, right? That looks much better. We do need to multiply that -2 into the rest of this, though. So -2 times y is just -2y's, and -2 times -5 is +10. All right, so when we get down to the end of that, this is where we want to end up. Right? So again, try out the next one. Right? It's pretty similar to what we just finished up doing here. Right? I know that these are definitely a little bit on the trickier side as far as problems go, but give it a go. Right? Try it on your own. So hopefully you did. Right? If not, I can't stop you, but hopefully you tried it. Right? This is what I got. Right? When I was going through and finding my slope, I needed to flip it so it's -4 over +5, right? That's my slope right up there. And I just plugged it into point slope form, right? Same old way we've been doing it. After that, I had to multiply. The multiplication got a little bit nasty. When we had -4 over 5 times -4, we get +16 over 5. Gross. So unfortunately, that doesn't really come out very nicely. Then we have to add 1 to it. But 1, if we're thinking about it as something that goes with the fifths, 5/5 is the same thing as 1. Right? So again, when we're adding and subtracting fractions, we add or subtract the tops. 16 plus 5 gave us this 21 over here. And then the bottom stayed the same. We still had it over 5. All right, so then we were down a little bit further to here. Right? We got this y all by itself. I needed to then add this 4/5 x to both sides to drag it over to the left. Then, after that, again, we don't want this leading coefficient to be a fraction, so we had to multiply by the number on the bottom of the fraction. That helped us cancel it out, right? So that 5 canceled out with the 5 that we multiplied with. So we just had 4x, 5 times y was 5y, and then it also helped us cancel out the bottom of that fraction on the other side, right? So instead of 21 over 5, it's now just 21, right? So, again, if you are feeling even a little shaky on some of these, please ask me when you see me during class, right? I'm not going to lie and say that these are easy. These are tough problems, right? So if you're feeling pretty okay about them, that's great. If not, that's also okay, right? Be sure to ask. It's the most important thing. All right, we got a couple more to talk through. I'm going to try and, respect your time and talk through them a little fast. So I want to figure out if lines are perpendicular or not, right? So what I need to do here, and this is going to be a little tricky because it's a little different than what we were doing at the start, is I need to figure out if these are perpendicular or not. So all I need to do is these ones, I'm just grabbing the slope out of them, right? 3 over 2 is the slope of this equation. We then need to compare it to the slope of the other one, right? The other one's in standard form, so we're going to do our, take A, slap a negative on it, and divide it by whatever B is, right? That one on the right-hand side, because it's -2, that's the same thing as regular old +2. So 2/3 is the slope over there, right? When we're comparing these, right, to figure out if they are perpendicular or not, right, there's two different things you could do. You could just look at them and say like, oh yeah, they're not opposite reciprocals. They're not perpendicular, right? But a foolproof way to be able to check is to multiply them together, right? So what I'm going to do is I'm actually just going to do that. I'm going to multiply, this first one was 3/2. I'm going to multiply it by the second one, which was 2/3. So when I multiply these together, right, the top multiplies the top. It's 3 times 2 is 6. Bottom multiplies the bottom. 2 times 3 is also 6. And 6 over 6 is 1. But for them to be perpendicular, they need to equal -1. Right? This does not equal -1. Right? So these are not perpendicular. Right? So that is a way that we can for sure test and make sure, if we've got the right answer on problems like these. Right? Try out the next one, right? Same idea. Figure out the slopes of those, multiply them together, see if you get -1. Right? Hopefully you did, right? If not, never hurts to try it. You can still pause, there's still time. Right? So on that first one, our slope is just -5, 6, right? It's just whatever's in front of the x. On the second one, we've got an a and a b. And what I'm going to do is I'm going to take a, slap a negative on it, and divide it by whatever b is, which was 12. Right? So kind of the nice thing about these types of problems is that I don't really need to even simplify that fraction, right? If you wanted to simplify it to be -5 over 6, you could, right? But, we can just multiply them together, right? That's really going to tell us all we need to know. So I've got -5 over 6. I'm going to multiply it by the other one, which was -10 over 12. And we're just going to see what they come out as, right? So up top, -5 times -10 is +50. On the bottom, 6 times 12 is 72, right? Yeah. So, unfortunately, that does not really work out, right? 50 over 72 is definitely not the same thing as -1, right? So these ones are also not perpendicular, right? So, that's how we would go about checking and seeing if two things are perpendicular or not, right? Last thing we got to do real quick is we got to take a look at it on some graphs, right? So I know that on yours, it doesn't show up as red and blue. So we're going to talk about them as line number 1 and line number 2, right? So for line number 1, right, the one that's on my screen in red, what we're going to do is we're just going to find the slope. And actually, line number 1, the slope is, and then to find that, remember what we did last time? We had to find 2 points on the line, and we would just rise over run to figure out what the slope is, right? So I'm going to find 2 good points. I want to have them line up with the grid lines as best I can. Right, so we can choose something like there, something like that point there, right? My rise, if I'm going from one point to the other, is to go up 1, so +1, right? As far as my run goes, to get from one point to the next, I need to run 2, +2. Oops, changed to blue halfway there. So my slope for that first line is 1/2. We are going to do the same exact thing for line number 2, right? We're going to find 2 points. We're just going to count it out and see how far it is from one to the other, right? So on that one, I'm going to choose maybe like this point there and this other point there, right? If I'm thinking about it as a rise and a run, right, my rise, quote unquote, is to go down 2. So because I'm going down, I'm treating that as a -2. My run is to go over 1 in a positive direction. It's a +1. Right? Once I've got those two, right, to check whether they are perpendicular or not, right, again, you could just say like, oh yeah, they're opposite reciprocals, no big deal, right? But to foolproof check it, I would multiply these together. I got 1/2 times -2 over 1, right? Let's see what that comes out as. The top multiplies the top, that gives us -2. Bottom multiplies the bottom to give us +2. And -2 divided by +2 equals -1. Huzzah, we did it. These are perpendicular. Right? That's all we need to get to, right? So I know that I've been talking for quite a while now. I'm going to stop talking. You might notice some stuff at the bottom of your page that is crossed out. That is on purpose. We are not covering that. But again, if you have any questions, especially about the parts where we need to deal with fractions, be sure to ask about them, right? We're going to practice this a little bit together during class and all that, but never hurts to still ask if you're a little unsure, right? That's it for now. I'm going to stop talking. See you next time. Bye.